Greetings and welcome to the Tom's Hardware Show, where we are talking about, choose your term here, bend gate, adapter gate, meltdown gate. What are you calling it, Paul?
Melting hazard. I would say fire hazard, but the chances of it starting a fire are pretty slim.
It hasn't started a fire yet.
Yeah. But there are now 10 confirmed reports.
10?
Well, it's quasi-confirmed. Yes, and
10-ish.
folks are pointing out that, the recent recalls, many recalls have actually been spawned from fewer reports or a similar number of reports. So they're starting to get into the territory with 10 reports because two reports from Korea emerged several hours ago, about an hour or two ago. And so now it's setting at 10 that we're aware of. And at that point, you start looking at, okay, is this recall territory?
Yeah. And
May or may not.
Like given the Igor Walasek
maybe
hardware alumni from Tom's Hardware, he dissected one of these lovely adapters, and he basically
maybe we
said,
should give the big broad overview.
okay, he said the things are not nicely built. Anyway, so yeah, there's a lot of people talking about these 4090s. So RTX 4090 has a 450 watt TBP, total board power. The adapters are 4-prong 8-pin going into a single 16-pin and can theoretically do up to 600 watts with the 4 prongs filled. I'm not sure how they actually even check for that. Like, I don't want to be the one to test it, but I suspect if I connected 2 of these, that the adapter would still work. So it's in theory you're supposed to use 4 separate harnesses to connect to it, and yeah, you can use less. You can use two connectors off of 1 harness, and the 8-pin harness is supposed to be rated for 300 watts at that point. It should work. It's worked for me. But the question is, like, what happens if this is not securely connected? Or if there's a severe bend close to this adapter, people are saying that can cause the internals to break down, to the soldering to crack, which then causes arcing and meltdowns and failure. So, yeah, we've got a lot of issues. What else do you want to tell us, Paul?
Well, for now, there is, just to be clear, there is no clear guidance from Nvidia beyond what it has published prior to the now becoming widespread reports of melting. So we can't say with any specificity, we can't specifically say that it is any one thing or give any specific advice on what to do to avoid it, because Nvidia hasn't confirmed or have they even denied anything at this point. I don't think they're saying anything.
They can neither confirm nor deny these reports. They're investigating, is what they've actually said to us.
They're investigating. They are investigating the issue. So we do know that they are looking at it. However, they have not confirmed that there's an issue or what is causing it. It could be, there are a lot of people that
I know where the bottleneck is. It's in legal right now. That's where the bottleneck is.
Probably in legal. They are recalling cards, supposedly. Again, it's not official, but we're being told that third-party AIBs are being asked to send cards that are impacted back to NVIDIA for further inspection. Some of the reporting that I have read is sometimes pretty misleading, where people are saying, well, it's the bending of the cables that's causing the issue. That's not actually the issues. It's the issues that can be caused from the pressure that bending the cable applies to both the connector. It can come loose a little bit, and that's bad, or to the soldering inside of the power plug. So as Jared alluded to, our former Tom's Hardware writer Igor Walasek over at Igor's lab has dissected a power plug, and it actually looks like a pretty flimsy affair, because though the GPU can pull 450, the cables are rated for 600 watts. That's some serious power over a single cable. There is no other single cable that will give you that.
Let me show you this for a second. This is the 16 pin next to an 8 pin. Do you notice how they're the same size? Actually, the 16 pin is smaller. It's got more wires, but I mean, like, you think of that, we're putting 4 times as much power through less area. That this seems like a kind of hubris design, like, okay, we can, but should we thing. And I mean, I've always wondered, like, was this that necessary? Like, I would have rather had, a connector that's a bit larger than the 8 pin that has, even if it has 16 wires or whatever they feel is necessary, and could consume and could use, maybe not even 600 watts, maybe rated for 300 watts. And then if you need 600 watts, you do 2 of them. Like, that seems like that would have been the sensible approach, but they went for smaller, more dense connectors. I mean, yeah, it's Clifford here says Andrew Han is looking at from EVJ is looking like a genius right now for pulling out of the 40 series launch. I mean, yeah.
There are some things when you look inside of that connector, we're talking about the physical size of the connector is smaller. That means that the metal pins that are being connected to have less surface area in order to be mated with the wire. So at this point, we're looking at smaller gobs of solder, because I mean, that is what it is. It's a nice little ball of solder at the end of each of those connections. So with the wires being bent and the fact that you have a lot of wires in a very small space with 4 cords, I mean, it feels like a recipe for disaster. And also, if you look inside, the pins are connected. They're all connected, not all pins, but the relevant pins, like the positive terminals, are connected by a foil. So, if you get a failure in one soldering connection, the current continues to flow all the way across, which would make me believe that at that point, what you have is an imbalance across the wires that typically should probably cause something in the power supply to click off. Overcurrent protection. Modern power supplies are very intelligent, and they will protect you from your own stupidity or the stupidity of companies. But when these types of measures are taken, it makes you wonder, is that what is causing the issue? Now, all reports that we are aware of right now come from Nvidia provided, and this could change, but they are coming from Nvidia provided connectors. There are power supplies, existing power supplies, that power supply manufacturers are retrofitting with a 16 pin cable that you can buy that you plug into it. So like Corsair, it's not actually an ATX 3.0 power supply. It's a ATX, I think it's 2.5 or 2.4 off the top of my head, power supply. But what they've done is they've made accommodations, and they've made a cable that you can plug directly into your power supply that goes directly to the GPU. We have not heard of any failures from those types of cables. However, those cables are not widely available.
Yeah.
But personally, I would be more just a personal statement for me, I would be more inclined to trust a power supply manufacturer with power delivery wiring. It's kind of what they do. So it's everything that they do. And these, I mean, look at these connectors.
These are for the record, I've tested 5 GPUs, 4090 GPUs right now. One of these cables is not like the other because it's not from a 4090. At the far left, my left, I hope that's your left as well, there's 3 8 pins. That is actually from an Asus 3090 Ti card, which the 12 pin connector can still slot into the 16 pin connector. It just lacks the 4 sense pins. But the remaining 4 adapters that you see here, they're all identical. They have Nvidia written on them with the little Nvidia logo, and I assume they're part of the card kit. So, the official adapter from Nvidia is what is being blamed by Igor's lab, at least, and it seems like a reasonable assumption right now.
Yeah, and to be clear, the spec, the 16-pin power spec, the 12VP, it's a terrible name. We'll just call it the 16 pin. The actual spec from PCI SIG should not be the issue. The spec is designed by the people who designed these things. This sounds like a bad cable design, bad soldering, bad QA.
I will say this though,
Perhaps
like both the 12 pin Nvidia's 12 pin and the new 16 pin, like is this PCI Sig that said those are rated for 30 insertions, or who was
it is
that?
PCI Sig, but you do
And
have to.
that's a concern for me as a guy who swaps graphics cards. I'm like, the 8-pin connectors, I mean, I've used those for years, swapping cards, plugging them in and out, and I don't know that I've ever had a failure, but I'm totally concerned about anything that's rated for just 30 insertions. I'm like, okay, most people probably won't hit that, but I sure as heck will, and now I have to worry about it.
And insertion ratings tend to actually be the 30 insertion rating has been there for quite a while on these types of plugs. And I'm not sure of what it is with the 8-pin, but I wouldn't be too shocked if it isn't much higher. Insertion ratings do actually tend to be low. Like for the socket on your motherboard, I think it was 150 for LGA 1200 at times that they think that you can change it. They do build a pretty big safety margin in there because we're talking about power and a whole lot of it. So, with these cables. So, I mean, I don't think the average user is ever going to get anywhere near 30, but folks like me and Jared are absolutely going to hit 30. I mean, on one review cycle, probably for me. I mean,
Yeah,
if I
I'm doing my
was so
best to
bold
avoid
as to unplug it.
Yep. I'm trying to avoid unplugging these, which ironically I've got all of them unplugged right now so that I can show them on the show.
Here's what's funny. This is also reminiscent of some of the issues that we've seen even before with some of the power connectors on the 3090. This is a 3090. Why is this mirror image messing with me? But anyway, this is a 3090 that I use and have used for about, I don't know how long
2
now.
years.
2 years for my only test GPU. I use the same GPU for every single CPU because that way we're getting good results. Like you could use 2 of these and one of them might be a little bit faster. Some people have made that mistake. You might see videos about them eating crow. Anyway, there were reports with some of these GPUs of these connectors breaking. So I use extension cords so that these cords here have only been plugged into this GPU one time, and since I've possessed it. They were plugged in once, and I have disconnected this like 1,000 times probably by now. I run CPU test pools of 20 plus easy. So, this isn't the first time we've had these power problems. And with the 16 pin now, it's like, whoa, power connector problems. And then with the 16 pin, it's like, whoa, here we go again. But like way worse. Because before when they were having failures with these on some of these certain GPU third-party designs, the GPU just shuts off. And now things start melting.
Yeah.
So that's not cool.
Okay, there's a bunch of comments. Let's see. So size isn't the necessary thing, but size is a factor because if you shrink things down, like you have less room for solder.
And you have less tolerance for things like heat.
Yeah. So also this plug's native to the PSUs using an individual cable going to the plug. Yeah. So this is interesting because wrong one. So you've got 4 connectors up top. You don't have to plug all of them in because there's this solder wrapped around the 12 volt pins on the 16 pin side. So there's 6 ground, 6 12 volt, and then 4 sense pins up at the top, right? But because all of the 12 volts are basically like wrapped together and shorted together, like you can plug in 1, 2, 3, or 4 8 pins, and I don't know that the card or anything, the adapter can see how many you've plugged in, but Nvidia says, yeah, if you plug in 3, it's good for 450 watts, and if you plug in 4, it's good for 600 watts. But yeah, it's also interesting to think like each of these 8 pins is actually 5 ground pins and 3 12 volt pins. So you've got, between the 4 of them, you've got 12 volt pins going into 6 12 volt pins
that are connected.
So it's like, it's kind of this weird thing. And I'm like, was there desire? Like, I don't know if you take this one, I haven't dissected this, but this is the 3090 Ti had 3 8 pins going into the 12 volt. I'm like, are these all shorted on the 12 volts on the 12 pin side? I don't know. That wasn't what I expected them to do anyway. It's just kind of interesting. So the option to use 3 or 4 or possibly 2 8-pin connectors leading into it might also be part of the design factor that is causing oddities and problems. Javier says wall plugs in Europe can provide 3600 watts. Here we talk of 450 watt. Why is it so hard? Well, because wall plugs have much bigger prongs. I mean, like, I don't know what all of the European plugs look like, but I think they're 3 or 4 prongs. The US prongs tend to be a bit smaller. The UK ones are these massive chonkers that can probably carry enough power from a nuclear power plant or something. But these, they're small. And I will say, like, I've had, like, a vacuum cleaner can pull up to like 1,000 to 1,200 watts in the US. And if I had a computer pulling 600 watts on the same circuit, the breaker will trip and the breaker might get warm. So yeah, I mean, we're dealing with different things. We're dealing with a much smaller area, smaller wires, all that stuff. I think the wires on your typical 8-pin connectors are, I think they're 16 gauge. Some of them might be 18 gauge. 18 being smaller. Sounds like a situation of bad upstream design. Nvidia trusted the external adapter manufacturer. Like, possibly. I mean, there are PCI SIG prototypes where they talk about melting connectors as well, and those weren't adapters. So, this is not something that they were totally unaware of as a potential to happen. So I don't know. It's a big mess right now for Nvidia and its partners to deal with. Hopefully it is just the adapter cable, because, how much could this cost, like, to have mass produced? If you're being generous, $10, and on a $1,600 graphics card, if Nvidia has to recall tens of thousands of these and they lose $10 each, that's not a big deal. If the graphics card itself is to blame, that's a much bigger problem.
Yes, I would be inclined to believe that we're looking at almost solely a connector, the adapter issue. But then again, we don't.
Yeah, I mean, like, whatever. If you happen to get a 4090, if you're one of the lucky ones who have it, I mean, so I will say this, like, I do a lot of swapping. So this is my power testing setup. It's an older 9900K, and, like, there's no case around this. It's an open test bed, and I've got 3 harnesses going into the 4 prongs. I'm a bad person, but even with just being plugged in, the weight of the cables is causing a bend in the adapter. But I don't think this is the type of problem where people are fracturing the solder and getting melted connectors. I've checked all of mine. None of them are melted. It's when, like on my case behind me, this is my 12900K test bed. The gap between the side panel and the graphics card is only like this big, and some of the cards are taller, so it's even narrower. I'm like, you try cramming a side panel on a case like that with this big adapter poking out, it's going to be a nightmare. So yeah, big cases, or leave your case side off. Don't put a bunch of pressure on that. Maybe look for a right angle adapter, third party. That might technically void your Nvidia warranty if you use a third party adapter, but I mean, a right angle adapter might be your only approach to fitting these cards in some cases.
Ironically, this whole thing came about because they want to reduce the size or the complexity of cabling and the number of cables required to go to the GPU, because the GPUs, like the one that I have for this Corsair HX 1500i or whatever the number is, the model number, is just a single wire. I mean, it is very, I would say, almost elegant. You get a whole lot of power over one single wire. And that's the end goal, is for everybody to use that with their power supply. However, as with anything with computing, be it hardware or software, backwards compatibility is a real pain, to put it nicely. So, this is the problem. We're stuck in this in between area where there's going to be probably the majority of people are going to be using these 4 cable connectors. And look, we're just dealing with this with the 4090. The 4090 is, even though I've seen a surprising number of builds over there in our Nvidia, and it seems like they're plentiful, this is the small volume SKU. So what are we going to see? Are they going to be cooking off like popcorn?
Well, the good
when
thing
they
is
start
that
pushing these high volume SKUs, who knows?
the larger SKUs use less power, and therefore, hopefully, these adapters won't have to be as robust. Like the 4080 16 gigabyte card that's coming out next is supposed to be a 320 watt card, just like the outgoing 3080, right? And then the 4080 12 gigabyte that was canceled, but we'll probably see some variant of that GPU show up in a 4070, was a 285 watt part. So
It's
power goes down.
It's conceivable that this could delay.
Yeah, they could.
It is at 100% conceivable that this could delay future releases until they get this worked out. Because, like I said, this is the Halo SKU. This is probably can't be. I can assure you, it's not more than 10% of the units. It's probably more like 3 of the entire product stack. So
if you look at Steam powered, you can see how many people are using 3090s versus 3080s, and it's a big jump in percentage to go.
Yeah, it's negligible.
So MSI's 4090 had just a 3 plug-in. I don't know which MSI card that was. I can tell you, I've looked at 5 different cards, including an MSI Supreme Liquid X, and they are all this identical 4-prong cable. The 3090s.
You just reviewed the MSI.
Yeah, we've got the Supreme Liquid X review up. That's not the one I wanted. This one. So Javier says Afterburner limits you to 100% with 3 cables. 4 limits you to 110%.
Yeah.
Oh, but that is that from the sense pins? How would that?
How would
they know?
Correct.
Anyway, I will say this: one of the card manufacturers said, "Hey, our card defaults to lower power," and I believe it was MSI actually, and they said, "Please launch MSI Afterburner and hit reset, and that will reset your power limit to 100% before testing." So that was, and I saw on another card as well that when I launched MSI Afterburner, that it was not at 100% at the default setting. So that was kind of interesting. I don't know what's going on there, if it's VBIOS or these adapters or whatever.
One thing's for certain, we know somebody who isn't going to be worrying about this problem.
Yeah, AMD. AMD is not using the 12 volt high power connector. They're not using 16 pin.
Yes, they're always quick to, they're seizing on the latest drama by saying, "Hey, not me, right? Not us. We're not using this." They Scott Herkelman, if I'm saying his name correctly, did confirm that AMD is not going to use the 16 pin connector.
Yeah.
So our DNA 3 will be hopefully not as problematic, at least.
But you'll probably, I will wager heavily that we see RDNA 3 cards like a 7950 XT or whatever that will use at least 3 8-pin connectors. I think someone, maybe ASRock or someone, did a card that had 4 8-pin connectors on it on the 6950 XT. I can't remember who it was, but I'm like, that is kind of obscene to have to connect 4 8-pin connectors, and a lot of power supplies don't even have 4 separate harnesses. So you're really you've got one harness with 2 connectors that you plug in, and it's like, well, how's that any better than just doing one connector?
What they need is an SLI-like bridge for these power connectors. They need a 16. It plugs into the 16 pin and it mounts the things facing up so that you can point them directly down. This is what we need. It's $1 million idea, people. It's yours for free.
There you go.
Because I just said it.
SLI bridge, except not SLI power.
Yes,
Paul's got
power
the
bridge.
answers. The other thing I wanted to talk about, and we'll try and cruise through this because we're trying to cut down our show time. So sorry, but I did some testing this past week of power limiting the GPU and showing what that does to performance. So you can see like voltage frequency curves, power curves, they all kind of go together. 100%, 100p is the default. Then I bumped it up. This is all on a 4090 Founders Edition. increasing my power limit without trying to overclock the GPU itself didn't help performance hardly at all. Dropping it to 90% hardly changed performance at all. 80% seems to be kind of in the sweet spot, 80-70%. And as you can see here, the next slide, this is what that does to your power, your temperatures, and your clock speeds. So if we run at 80% as an example, overall, power dropped by, let me get the right number, 12.1%. Performance on average dropped 3%. Efficiency improved by 10%. And so we went from an average power use of 400 watts, 402 watts, down to 350 watts, and hardly lost any performance. So
yeah, see, that's a really great. Yes, as they go up higher, every extra little bit of power or every little extra bit of performance, once you get to the top of that curve, it costs a lot of power. So these are at least some reasonable things. Here is actually, I did see today on our Nvidia's 2 different posters, people who were showing their systems and saying, I can't use my card because I'm afraid it's going to melt. They are panicked. One guy's, the title of his, I shared it to our newsroom because I found this to be a tragedy. He said,
first world problem.
I bought an expensive GPU just to not use it to avoid melting the bleep power adapter. I'm using the Intel integrated GPU UHD 770
Woo!
instead. Man, spent how much do one?
1,600 minimum.
1,600 minimum, man, to use integrated Intel graphics, man. So this would be, maybe.
So
individual should power limit their GPU, get a little safer, and not lose much power.
Yeah. So I said like 70%, 80% seems to be the sweet spot. But just for reference, if you want to drop your power limit down to 50%. Average power use across our test suite was 224 watts, and we're fully power limited at that point in every game. So like I tested 8 different games, and every one of them shows power of 224 watts. It ranges from 223.6 to 24.2 on the power use in the games that I tested. So, like you're then totally pegged by power. Performance dropped on average by 25%. So you do lose a fair amount of performance. But at the same time, I'm like, if these adapters can't handle 225 watts of power, like that would be shocking to me. Pun, shocking. But don't bend them. Don't put a bunch of stress on them. Try to keep them as straight as possible. Leave your case side off and run with a power limit until we get an official answer from Nvidia. I'm comfortable doing that. I'm still testing GPUs anyway, even these 4090s. I just try not to do anything that will cause them to break.
My personal opinion is I would not do anything except use a cable that runs a native power cable that comes directly from your power supply to the 4090. That is all I would trust at this point.
That's the ideal solution.
That is the ideal. Unfortunately, not everybody can do that.
Yeah.
When I received this from Corsair, they had to actually overnight the cable to me from Taiwan. So, because they at least at the time, which was like a week ago, 2 weeks ago, it seems like a year, they were not available in the United States at that time. So this isn't an option for everyone, unfortunately. But I mean, it is for me, luckily. But I mean, I'm so skeptical right now.
Javier says Intel graphics cards are super expensive. We're not talking about the A770. We're talking about the UHD 770 graphics.
Integrated graphics, because
UHD 730. UHD 730.
Like that thing that gives you a slideshow at 720p in some cases, right?
Yes.
It's like the poor person. This individual is very unhappy.
Yeah, I bet.
I feel unhappy just for them. I feel their pain, sympathy pain.
Sympathy pains, that's right. My wife taught me all about those back when she had kids. So the problem with finding a native power supply cable is like every power supply manufacturer is basically different. So if you have a nice Corsair power supply, you can go to Cable Mod and probably find an appropriate adapter. It's a third party. Nvidia might say it voids your warranty. I don't know.
NVIDIA does say that they void the warranty in their documentation. We've asked for clarification, have yet to receive a response. They will not say.
I actually looked for warranty. They don't say that it voids your warranty. They say don't use any other third party cables. And I'm like, well, a power supply, direct power supply to the card cable. I mean, like all the ATX 3.0 power supplies with native 12-volt high power connectors are technically not NVIDIA's adapter. They would be third party. So I'm like, well, that's stupid. So we've asked for clarification, but
we've hit the big time. We have spam.
Yeah, they're gone now. But the main thing is, like, if you've got a Corsair or a name brand power supply, check out Cable Mod, see what, or other places like that, see if they've got an adapter available. That would be almost certainly safer than what we're dealing with right now. That's not the official NVIDIA recommendation yet. I can't help but think there's going to be a recall. Like, I just don't see how this can continue without it.
Recall of the cable, at least. I mean, they probably like, wouldn't cost too much to overnight a bunch of cables.
Yep, it'd be a drop in the bucket compared to the cost of one house catching fire.
Correct. Or like any, yes, one. Correct. Yes, and yes.
So there have been recalls over lesser things in my experience, and I mean, this is the second time NVIDIA has had issues at launch. When Ampere launched 2 years ago, the 3080 and 3090, there was this whole capacitor brouhaha, cards were unstable. It was, in my experience, it was the third-party cards that had pushed higher overclocks, factory overclocks, were unstable, and driver updates fixed that. But you can't fix this one via drivers, I'm pretty sure.
You know, the reality of product design is that every single product has some amounts of failures, and they are aware of this and cognizant of it when they ship it. They say, okay, if we put a more robust component here, maybe it's a slightly better VRM, it's going to cost us $5 more per unit. If we don't, we're going to get X number of failures per year from this, and we're going to have to replace those. And say, okay, well, it's cheaper to replace those than it is, you know, it's 100 times cheaper to just do the replacement than to make this fix on every single card or whatever product it may be. So they determine that it's not financially feasible, and they'll just eat it. But those aren't safety problems, and typically, and even if they are, the big thing here for NVIDIA is not so much the cost of fixing this, or it's the damage to the brand. When you start having concerns about safety, they almost have to do something, even if they step back and say, you know, really, this is not going to cause a fire. It's just a little melting. And, you know, it's X%. I think that at some point, somebody's going to sit down and say, the damage to the brand far outweighs any of this. How long can they take these headlines?
I'm waiting for the AMD advertisement that basically says AMD, the safer solution for your graphics.
Yeah, the damage to the brand is going to be almost incalculable if this continues, especially when they begin shipping high volume things. So even if this is like a minor problem or like there's some little thing, I think that they should go overboard in fixing it.
Yep.
That's what I would recommend.
Any questions we need to answer over here? If I left the front panel off and actually supported adapter harness to where it's straight out and actually lowered my GPU and CPU temps. Probably better airflow would be my guess, but yeah. Who was it? Be Quiet did some testing of basically bent cables versus they did like a improperly connected cable. So like they pretty much, if this was supposed to sit flush, they had it like either slightly skewed or whatever. And they showed that when it was properly installed, clicked into place firmly, the temperature was like 50 degrees Celsius. When they improperly installed it, the temperature shot up to 100 degrees Celsius. So, you know, there's that question. Are any of these improperly installed? Possibly, but I suspect more likely is that it's just the soldering broke inside of it, or something went wrong inside the adapter, and that caused the the power spike and the heat spike that melted it. Anyway, that's it for today. I will have a full article showing all of the gaming charts for power limited testing. That should go up today. So keep an eye on Tom's Hardware for that. Otherwise, thanks for joining us, and we will be back next week.